Let's take a look at how the architecture of the data flow in RIS works with respect to our graph node and our patterns and textures feeding into materials, feeding into the integrator and the final image. Let's take a look at the conceptual level, and then we'll dive into Maya to see it in action. So let's start out with a pattern. So what is a pattern? We're going to represent the node by a rectangle here and see how it plugs into everything. A pattern could be a procedural, so that means a mathematical way of doing noise, fractal noise, any kind of pattern that's generated with an expression. And also it could be a texture. So a texture could be, like we see here, a normal map plugged into a specular or a bump. And this is a tangent map, so it's a mudbox tangent map. That's one type of texture that could be a pattern. Another one just could be a color map, like this nice flower print we're going to see on the tablecloth in the still life. Now this is a procedural, so this is a Voronoi pattern, and that can be plugged in as a pattern, as well as this cool FBM noise is what we call it. It's a layered noise, and all of those can be patterns, and the patterns get plugged into, and we'll see with this arrow, into a BXDF. So BXDF is our material, and in previous versions of RenderMan, pre-RIS, we kind of call this a shader. So if you're used to using shader, you can call this a shader, but the difference is before a shader always determined the final color, but we'll see here with the integrators that a BXDF really doesn't supply your final color. It does the sampling, and it sends that information to the integrator, which actually writes the final color. So our BXDF has things called closures, but ultimately it's a material, or if you've heard use the word shader a lot, that's certainly something that is pretty much the same thing. And here it could be a glass, like we see in the renders here. It could be metal. That's a different kind of BXDF. It could be subsurface scattering. So they're all the different like shading models. And we have a double arrow here because that goes back and forth with this thing we call the integrator. And there's a lot of back and forth with the integrator. The shader does a lot of the sampling of the material with the BXDF. And the integrator can be something like the path tracer, which is the default in RenderMan. It could be a utility integrator that just gives you information like surface normals, UVs. There's a lot of different stuff we can do with the integrator, and it talks with the lights as well as the BXDF. And here we have some render examples of different kinds of utility integrators. We can see UVs and can do a lot of different cool things. And this is the path tracer here, which is ultimately the final render. So the integrator actually writes the pixels. And our last thing is the image display. So this is basically our final render. And we're going to have the same renders that we see on the integrator because the integrator actually writes to your image display. So this is the flow of data. We're not using lights in this one. The lights have a big part of the render, but here we're just looking at like the pattern and the graph node connectivity. So we'll jump into Maya and do a simple example, and then of course we're going to do more complex examples throughout the course, but we wanted to give just an overview of like how it all gets connected. And it's really important that the first thing upstream is the pattern node, which gets plugged into the BXDF, and the BXDF talks with the integrator, and we have like different modes of the integrator. We'll see those in our options in RenderMan. And then finally, it writes our final render. So that's how it all goes together. And of course, when you start layering, you'll start layering the BXDFs and the patterns, not the integrator. So we'll see that. So let's take a look at it in Maya and set up a really simple example. Before we jump into Maya, let's just take a look at a slide here of what we're going to initially set up. And this is the node editor in Maya, and I've got the RenderMan controls here as well. So just like we saw in the previous slide, we have our pattern, and that could be a file. And I've removed the upstream node because there's some file information for UV placement, but in that pattern node, we supply our normal map, our color map, etc. And then this is also a pattern. We mentioned we can get fractal noise, Voronoi noise. So there's a lot of different procedural things we can do with the pattern, and that could be an OSL, custom OSL shader. It could be an SE expression. That's a really cool expression language for making patterns. I like using that. or it could be some of the built-in noise functions that ship with RenderMan or Maya, called PXR Fractal, PXR Noise, all these different ones. And those are all plugged into different slots into the PXR surface. So the diffuse color here, specular face color, etc., etc. We can really plug them into anything that inputs, that takes an input as a color or a floating point, black and white. And then finally, we have our integrator. So we just wanted to show that here. By default, it is the path tracer. We'll go into much more detail about the different integrators. Here, we just want to see how they fit in together with this whole pattern BXDF integrator final image connectivity. And again, just the defaults on the path tracer, we can see the max path length, sampling mode, etc., etc. But that's where you set that. The integrator is a global setting, whereas you can see with the BXDF and patterns, we can layer those. We can get pretty crazy in the node editor, and we certainly will. But these are the things. So let's set this up in Maya from scratch, and then we can build on top of that. So in Maya, we're in our node editor window, and we can do that by going panels, panel node editor, or, which is down here, or under Windows node editor. And I'm going to hit tab, and I'm going to type in PXR surface. So that's our BXDF. And another way to do that is if we click on the create node pane on and off, we can toggle that. And under RenderMan here, we can really browse around, and under materials, I have PXR surface. So that's one way to drop it in. Patterns, displacement. It's a great way. Just go ahead and browse all these menus so you know what is in RenderMan. However, if you want a quick one, you just hit tab, and I like to type in surface and just go to PXR surface. I can really see everything that's available to me based on that name. So either way, so that's our BXDF like we saw in our diagram. And if we go in here, let's connect a texture upstream. So just simply for the color, I can add on a file, as I mentioned. And that file can be our cloth pattern. And it could also be, if we wanted to add a procedural, I'm going to go to the specular color, and under here, under RenderMan, if we go under patterns, we've got checker patterns. So these are procedural patterns, fractals, like I mentioned. So we do PXR fractal. Now we take a look at our graph. We can see our specular face color is going to be a fractal, and our diffuse color is going to be pattern. So this is just again a very simple example of what we saw there of patterns connecting into BXDFs. Now what about that integrator? Where's that? Well, I'm going to go under RenderMan menu, Advanced RenderMan Controls, and here we see under sampling integrator, and here we can go through all the different integrators. And again, we'll go into these into more detail, but we just want to show the overview here. And that's a global setting, so you can't like layer your integrators. You just set that once, and then that actually sets your final pixel for your render. So let's apply this just to like a simple piece of geo, just so we can see it in action. So I'm going to go into my 4-pane view. Let's keep our node editor down here, and I'm just going to create a NURB sphere. I'm going to zoom right into that. I'm going to create a polyplane, make that a little bit bigger, hit R in Maya, expand that out, and let's drop in a light. Before we do that, let's raise our sphere a little bit. And under the light menu in the RenderMan toolbar in the shelf here, you can right-click the light for options. And then under IBL, you can right-click the light for options, so dome light. I like this daylight because it drops in a nice little time of day, and we can bring our exposure up. So let's just see what that looks like right now. What have we created? We're going to go 4 up again just so we can see our PXR surface in the node editor. And I'm going to hit an IPR render. Oh, we forgot to assign our PXR surface, so let's click on that. And that right-click, assign. That might get you in trouble. That might get you in trouble if you don't assign. So here we have a nice noisy image because we're doing our IPR render. And like I said, I love that daylight light. And it's quite rough. That's why we're seeing it quite noisy. So if we go into PXR surface and in our specular take the roughness down to like 0, it'll be a shinier object. But we can see we have this neat flower pattern and specular on top of it, so it doesn't really make sense because, you know, when would you have this kind of a setup? But just a basic setup to show you those patterns going into the BXDF. And now if we go into our integrator, so I'm going to go into RenderMan controls, and under sampling, integrator, and if I start changing that into like a debug shading context, what I love about swapping out the integrator is you can what's called hot swap it, and while your IPR is rendering, you can change all the different settings in here. And I'm going through our surface normal, V length, so that's a camera based one. So if you go, for example, to V length, you might say, well, we're not seeing anything. But if you actually play with the exposure up and down, it's kind of a depth. It's a camera-based depth. So that's nice having those monitor controls in it. And shading tangent, inside, outside. So there's a lot of different options. Again, we'll go into detail of these, but the point is the integrator is a default. It's a global setting, and we're at our default integrator, so it's just viewing our actual patterns there. And this is really fast, so because it's doing it at the integrator level, you don't have to change things upstream like your BXDFs. Normally before, you have to go into your shader and change all these things to see, but doing it at the integrator level, this is a bidirectional path tracer. It's a lot more complex. You can just really assign it once, and then it does it for your whole scene, so it's a really nice feature here. Finally, the visualizer is like a really quick one. So that's a very simple setup of a pattern going into BXDFs being controlled by the integrator, and we'll build upon this throughout the course. So if we look in our Maya scene, and in this scene, this is our still life that we'll be using throughout the course. And let's take a look at the tablecloth. And if we go over to just a quick preview render of this in it, that's our camera view right now, and we're looking at the tablecloth. So what does that look like in the node editor with respect to this lesson on pattern graph node connectivity? Well, we have our tablecloth material. This is the BXDF that we're talking about, and we can see here it's PXR surface. That's a really nice monolithic BXDF, new for 21. And upstream, we have our patterns going into our BXDF. So in this case, we have our flower pattern, which we can see here. That's a black and white bump map, and it goes into the input bump, and that goes into the bump normal. So again, you'll see other nodes in between the textures and the procedurals. For example, if it's a bump node, because it has to do certain things to the surface normals. So that's kind of an interface, but the gist of it is a pattern. And then we also have our actual texture pattern, so we can see just a preview of it. And if we click on the folder icon, of course, we can see all these textures upstream, but we also have procedural. Remember we talked about the procedural patterns? Those are the two different kind of patterns. In this case, we have a PXR fractal, which is a turbulent noise, and that's blending in with our flower pattern. So that's a blend node, PXR blend. And what that does, it just gives it a little bit more noise, just to give it more realism. Otherwise, it looks too like fake CG if it's just a clean texture. And again, this is like an interface node in between. So it's doing some blending, but the gist is that it's these patterns going into a BXDF. And if we look into our RenderMan menu under Advanced RenderMan Controls, we'll take a look at the integrator under the Sampling tab, and it is our path tracer. And these are the different kinds of integrators that we talked about. And ultimately, they talk to the BXDF and render our image. So let's just kick off a render, even though we can see it in the IT window here. I'm just going to kick an IPR render off. So we can see it in action. And there it is. So what happens if we change the integrator? We get a lot of cool settings at the integrator level. So the advantage here is we don't have to change the materials. It's all done at the final integrator level, which talks to the BXDF if needed. But for some of them, like this really handy occlusion, it doesn't really need to talk to the BXDF materials because this is all done at the integrator level. And whatever your integrator is, remember, it actually writes the final pixels to the screen. Whereas before, if you're used to a shader from previous versions of RenderMan, the shader would actually write the final pixel to the screen. That's why we're calling it a BXDF, because it's really the integrator that's communicating with it and the lights and then writing our final pixels to the screen. So that's a nice example of the pattern graph node connectivity. Just to see the big picture here, of course, we're going to dive deeper into each section, but how it relates to the overall architecture and data flow of this RIS system and the integrators with the BXDFs and the patterns. Let's zoom in a little bit on the integrator and the BXDF, and in particular the communication between the two, as we can see by this bidirectional arrow, because there's a lot of stuff going on here with the bidirectional communication between the two. And we're going to do a little bit of an overview here just to explain what's going on. It can get obviously quite complicated, but let's take a look at what some of these differences are in what's happening in the BXDF, what's happening in the integrator, and just to see what the changes are from some of the older systems where it was more of a shader, was doing that final sampling and that final color. So on the BXDF side, we're going to go just through a few notes here, and the BXDF samples only the material. So it evaluates and generates samples for your particular material. Again, depending if it's a metallic object or glass, etc. But it only does the material sampling. It doesn't actually throw any rays. So there's no ray tracing happening inside the BXDF, whereas before when you had shaders, you could do ray tracing in here, but all the ray tracing is done in the integrator. We'll see that on the column on the right. So no ray tracing in the BXDF, and it's only doing the material samples. Now this what provides a closure to the integrator, and a closure is not the final color. It's a representation of the material. So it's the material samples that are evaluated and generated, and it tells the integrator what kind of rays it's throwing, whether it's a specular, diffuse, refraction, etc. And also it has to know if it's doing the front shading, if it's doing the front or the back, if it's doing the front and the back, for example, hair. It also has to know if it's like inside, outside the material. So these kind of sort of geometric shading information of the material, the BXDF handles that and communicates that to the integrator. On the integrator side, we've colored it blue here just so you can distinguish it a little bit. So it does all the heavy lifting. So it's doing all the ray tracing. It's throwing, if it's doing refraction rays, it's letting the BXDF know that there's refraction rays happening, so it has to evaluate the material sample there, but it's actually doing all the ray tracing inside the integrator. And with the bidirectional communication with the BXDF, it's also doing a similar kind of thing with the lights. And in this diagram, we don't have the lights, but it's similar with the light plugins. The integrator is doing all the heavy lifting, and it's communicating with the lights as well. And as an example, as we mentioned before with the BXDF, the integrator actually does the ray tracing of the refraction ray, but it passes that to the BXDF to do the material sample for that refraction. And also, it's doing MIS, and that's multiple importance sampling on the BXDF and lights. So it looks at, is it a shiny material? How big are the light sources? And it does this advanced importance sampling on both the BXDF and the lights to determine the best way to do the render, and it does some probabilities, and it focuses all the important ray tracing towards the important areas of your scene. Again, if you have a fully diffused BXDF, it's going to have to take a look at that, as well as how big the light source is, or if you have a shiny BXDF. So all this stuff goes into MIS, and the MIS is obviously quite complex, but here we just want to touch on a number of the important things that is going on between the BXDF and the integrator. And of course, there's a lot more happening in here, but this gives you a real good idea of like what's not happening in the BXDF, for example, the ray tracing, and where all the heavy lifting is happening. So you can just understand when you're making complex scenes, just a little bit of the technology behind it. Let's add a little bit more complexity to this chart that we have, so we can see a little bit more of what's going on. So we started with the pattern going into the BXDF, the bidirectional communication with the integrator. Now we also mentioned there's that bidirectional communication with the light source. So we'll add that there, and the integrator talks to both the BXDF and the light, and we mentioned that's where the multiple importance sampling is happening. There's also a thing called light filters, and that happens between the light and the integrator, and that just basically takes the result of the light and can filter it out if you want to do different kinds of things with barn doors or patterns or a lot of neat stuff in the lights in RenderMan. It happens before it gets passed into the integrator, so that's a little addition to add there. Also, on our left we see displacement, and that happens on the geometry. That actually happens first. That happens before the pattern is evaluated. So that's the first thing that happens because it happens on the geometry. So we wanted to add that at the end, and we could have gone through all of this right in the beginning, but we didn't want to make it too complex, focus on the core. Now we're just adding in some of the other complexities. And then finally, we'll see before it gets to the image display, there's things called display filters, and before these were called imager shaders. And once the integrator is done its heavy lifting and evaluating in 2D, in two-dimensional space, you can add display filters to add really cool things like lookups onto the final rendered image before it gets thrown to the display. You can do other sampling filters on the actual sampling, and this is where the anti-aliasing happens. So all the stuff that happens in 2D happens here, and you can modify it with a display filter. So this gives that overview, and obviously can get quite complex, but this lets you know what happens when, and the communication between each other, and where all the pieces fit into play and this data flow in RIS and RenderMan. So back in our Maya scene, how do we set up some of those extra features that we looked at in our overview, like the displacement and some of those filters like the light filter and the display filter, because they're not necessarily obvious because you set them up in different areas. So let's take a look at our displacement. Now we're back on our tablecloth material. So if we look through our camera and zoom into that render that we had before, we just have no displacement on here. So we're going to go ahead, and the PXR Surface BXDF is connected to the shading group. So if we click on that in our node editor here and click on our shading group tab, we see our surface material is connected, but the displacement material is where we're going to add that displacement to go on top of our geometry. And just like a lot of stuff that we're touching on in this class, because we're seeing how it's all connected, we'll go a lot deeper into displacements in these courses, as well as some of the other filters that we're going to touch on here. So I'm going to click on this checker in my displacement material. Remember, we're in the shading group, and under RenderMan, where we can look under displacement patterns. Those actually plug into the main displacement node, but under displacements, we have PXR Displace. So if we drop that in and we can zoom out in our node editor, we can see that it dropped in this PXR Displace node, but it also dropped in another shading group. Now, you don't need this extra shading group that it drops in. It just kind of does that automatically, because if you just drop in the displacement node, it needs a group, but we can delete that because we already plugged it into the displacement shader of our shading group. And you can do a bunch of different stuff here with the displacement, scalar vector, etc. And you can do some upstream nodes that do the vector displacement. Again, we'll look further into that into future courses, but we just want to know how to set up a displacement shader here if we wanted to do one for our tablecloth, just to see how it fits into the big picture. And also, we talked about the light filters. Let's take a look at those. So I'm going to go ahead and look into my outliner in the lights group. And just for my key light in the scene, if I go under light filters, there's a little option, light filters, and I right click, and I can create a number of different ones, starting from the barn light filter, cookies, gobos. There's a lot of cool stuff we can do with these new lights. And we've got a light rod filter that I'm going to drop in. And that has a number of different options for this really cool light rod filter. And if we zoom out, we can see that we actually can see it in our node editor. So there's a PXR light rod filter. We can see it in our outliner as well, and our light rod filter shape. So that's just the shape node. But that's how you drop in a light rod filter. And again, we'll go into more detail of those in a class where we dive further deeper into that. So that's how you set that up. And finally, we had our display filter, or an imager shader. So if I go into the RenderMan menu, so under RenderMan, Advanced RenderMan Controls, and we have all these tabs here at the top. If we go from our samples, we can go over to the features, and under features we have filters, and this is where we want to add these. So we have display filters and sample filter. So this is where your imager shader goes. We can do background display filter, grade display filter. So we pop that in. We can close this. Again, if we zoom out, we can see that in our node editor. So all the different components are in different sections of the settings. That's why we wanted to drop all these in. And now we've got our grade imager, display filter in there, our light filters, our displacement. So that's how you bring it in Maya. And in the next little section, we'll take a look at the actual rib file, like where that all sits into play, so you can see what RenderMan is actually seeing when you're rendering outside of Maya. So we've seen this pattern graph light node connectivity at a conceptual level and even in Maya with our user interface, but how does RenderMan actually, like what happens under the hood? Like if you're curious to see how RenderMan actually treats this, that's what we're going to take a look at now. And what we're going to do is we're going to do an open last rib in Maya, and we'll go through Maya and do that later. We want to explain it first just to pull the gist out of it, and then we'll actually do it in Maya. So if we do that, RenderMan writes a rib file, which from Maya is actually what the core RenderMan renderer uses, and it's actually readable, and it's great for debugging and seeing what's actually going on under the hood. So if you're ever curious about that, this is what we'll talk about. So we've pulled out just the gist of our patterns and BXDFs and integrators and put it here in the slide, and then again we'll see it in this huge rib file later on in Maya. So that first line, this is exactly how RenderMan writes it, and the renderer sees it. So you can see it says integrator, and then it has information about the path tracer, which we're using in this case. And I put ... because there's a lot of other information in there, but that's how RenderMan reads it. That's the exact kind of format there. And then later on in the rib file, it'll say display, and it'll have the EXR file. So that's our final pixels being written to the screen like we saw in our diagrams. Then we talked about that display filter. That's something that happens sort of as an imager shader, and we dropped in that PXR grade display filter, and that's how it's written in the rib file. So that's where it goes, right? And this is, by the way, these are in order. So the integrator happens at first, then there's a bunch of other stuff, display filter, so we can see in what order RenderMan puts it in that rib file. Then we added a light filter, so this is what that looks like. We added a light rod filter. Then there's the actual light, so if it's a rect light, like a rectangular area light, this is how the RenderMan rib writes it out. So you can look for that. We added a displacement shader, and that new call is just called displace. It used to be called displacement, now it's just displace, PXR displace. So if you're looking to kind of debug and see how your displacement shader is working, you look for that. Then we have a bunch of pattern nodes. We have that fractal, and we have the texture file, and that's what RenderMan sees there. They're both patterns, whether they're file nodes like a texture, or a procedural, or a custom plugin like an OSL shader. It just lists it just like that with a pattern. And then finally our BXDF, and in this case it's PXR surface, and we're using this example with the tablecloth, so that's what that line looks like. And after all that, it has the actual geometry. So in this case it's a delayed read archive, and it assigns the BXDF to the geometry. All those other nodes are upstream, the patterns, the displays, and then our global integrator gets put right at the top. So in the next little movie section, we're going to actually do this open last rib in Maya and just see how big that whole rib file is. But I wanted to, before overwhelming you, I wanted to just kind of pull out the important stuff here. And then with your scenes, especially when you have smaller ones, it's great to just do open last rib and just to see what RenderMan is seeing, because then you understand, regardless of Maya, regardless of Houdini or Katana or any other bridge product like the 3D package that writes to RenderMan, the plugin, when you're looking at the rib file, even though it's obviously quite complicated and a lot of text, you know what actually RenderMan is doing. And if you're ever to take that scene into another Bridge product or another studio, if you understand a little bit of this, you understand how RenderMan is working, and you can solve a lot of problems just by looking at what it's writing into the rib file. Let's see that in action. We saw a highlight of that rib file on the previous slide, but how do you actually do it here? So I'm going to hit the space and the RenderMan diagnose menu. So I'll keep that up. And if we do open last rib, if there is no rib on disk, it'll ask you to generate it. So we're going to hit OK. And if it's just set for one frame, it'll just do one frame. If you have an animation set, it'll go and generate all those ribs. But here we can see the latest one, and there's a lot more stuff in here. We can see we have just a lot of things in here. That's why I simplified it for you in the slide, but I just wanted to show you how to get at it in the actual Maya. So if we search, for example, tablecloth material, we saw that. So here it is in here. It's a lot messier, but we can see the BXDF line and all the information there that we took out when we were looking at it, because we really wanted to just get the gist of it. But you can see all that in the rib, and you've got the pattern nodes upstream, and you've got the displacement with PXR displace. If you search for that, you can see the PXR displace upstream. So again, this is great for debugging. It really shows you what Maya and the RenderMan plugin for Maya is exporting into your disk rib file, and then RenderMan, the core rendering technology, will take that and render it. And again, whether you're rendering in any kind of different package, if you understand the rib file, you really get an understanding of what RenderMan is doing. So that's how you do the open last rib. Great for debugging, and you can really see how everything gets put into RenderMan there.